You guys?
We're Jack LeMasney's kids.
Are you giving a presentation tonight? Are you?
Scratch.
You are?
Yeah.
Okay. What do you know about Scratch?
Oh, Dad taught me everything, but I'm very skilled at it.
I'm playing video games while he's doing it.
Okay.
He's playing video games on his turn right now.
But you both know Scratch. That's great.
Yeah.
By our friend Jack LeMasney, and just to prove that there is hope in the future, we have the next generation of LeMasneys with us. So I'll turn it over to them.
Thank you very, very much. As always, I am delighted to come to this group because I think that, as I've said before, a bit of a repeat of what I've said before, this group really cares about its membership. It cares with great passion about technology. And I don't find that everywhere. So I'm always happy to come back to BCUG. I'm always delighted to be asked to come back. And I'm sad to hear that Joe, at some soon point, is not going to be the one making the call, but I'm sure that we'll still have conversations.
Well, I definitely like being at this group for the first time. It's very interesting. I was looking at the things right here. What I understood looked very interesting. I hope to come here sometime in the future.
Jack was really excited because he heard some of the topics that you had coming up. And he said, why don't we come here every week? And I said, because we're about an hour away. And you know, as much as I would be delighted and as much as we'd all be delighted to come, of course, you know, I don't get here nearly as much as I'd like. So with that, I'd like to introduce my son, John Jr. This is Jack LeMasney. And up there in the corner, of course, delighted with my next seven is David, my other son, David. So tonight we're going to talk about three topics, and Jack is going to help me with the first, which is Scratch. Scratch, of course, is a block programming application, and the other two are hardware-based solutions that happen to be open source hardware-based solutions. Hold on just a second, let me get set up. So, my presentation, incidentally, does not talk about Scratch, and Scratch is the part that Jack's going to help me with. We want scratch.mit.edu. Now, let me tell you a little bit about Scratch before we get into our demo. So, Scratch is a block programming application, and it used to be a standalone, still is a standalone application that you can download and install on Windows, Mac, Linux, etc., Unixes. And what it allows you to do is to very simply create a program set of instructions, similar to other programming languages, scripts, etc. And it is oriented towards younger folks. But it is interesting from an introduction to programming standpoint. What I really love about it is Jack, who's about to turn 9, is very, very fluent in Scratch. And since they moved from the standalone application to a cloud-based application, we were able to create an account there, log in, and then any work that he does from any machine is saved onto that account. And you log in like any other cloud-based application, and all of your previous work is there. Right, so I'm going to sign in as myself. So the first rule of speaking in public, and today is Jack's premiere, is not to reveal your password to a crowd. As you can see, even though I'm not signed in, here we have the interface for Scratch. And this character here, referred to as a sprite, is is a character that we can manipulate. So I'm going to ask Jack to go ahead and do some things with this sprite.
Okay, so the first thing I'm going to do is make it move. So you see the mouse is on this move 10 steps right here. I guess we're kind of doing the intro here. Okay, first we're going to do this, move 10 steps. Let's say this might be a little bit of jumping forward, but when the green flag is clicked.
Where's the green flag at?
Green flag's right here, right here.
Why would you put that there?
Because, look, then I say, let's say, move, whoops, move, how do I,
You want to set that apart? Set that aside?
there we go.
Oh, there you go.
What? There. 1 steps, then, so this says, when green flag clicked, move 1 steps, then stop all. Okay, this has a down arrow because you can, like, change that. And so,
So why don't you run your script?
yeah, why don't we run our script? So when we press this green flag, it's supposed to.
It's moving
Okay.
just a bit.
Can I guess I can't do that. So let's go. Wait 1 second. Move 5 steps. Then stop all. Now I'm going to move this guy. If you click on this guy, just click and hold. You can drag him around. I'm going to drag him back here so he doesn't run off the page. And we're going to press this. Then press this again. If we keep pressing this, eventually he's going to get there.
So
He's moving 2 steps.
what if you wanted to have him walk forever?
Then you could do this.
You see how he's just removing his commands.
And then we go 1, 0, 10 steps. Then we click this.
Oh, I was talking about the forever loop. Can you add a forever
Oh
loop
yeah,
to your-
yeah, that's a great idea. Okay, so there's this forever block. We put that in there. We press this, and we do this.
Thank you very much. Jack LeMasney. His first time in front of an audience.
He was great.
So, the beautiful thing about Scratch, especially for younger folks, is that it's fairly easy to comprehend, fairly easy to set out a series of tasks, and fairly easy to accomplish those tasks. And the programmatic knowledge that Jack has learned, for example, is able to be applied to other languages. So when Jack is introduced to JavaScript, it won't be foreign concepts. The idea of a loop, a for loop, or an if-then statement are all things that he will have already encountered in Scratch. And so it won't be the first time that he encounters that idea. The reason this is important is because there is a growing importance for the ability for children not only to read, write, and be able to accomplish mathematics, but also to be able to program. As we move forward in time and more of the interactions and information and knowledge moves to the web, it becomes more important for them to be able to manipulate the way that that information flows, which happens to be web-based and through applications and through apps and through mobile platforms. So I'm excited for Jack and I'm excited for David because they are starting to learn these skills. Hi, David. So that is Scratch. And we can go back in that if you want to do some more experimentation, or maybe Jack will show us something else in a little bit. But we're already at 8:35. So
this came from MIT. Any connection at all with Logo?
it's a similar idea to Logo. It's really an extension of BASIC and Logo.
Right.
You know, that cat is the turtle.
That's right. That's what I'm thinking of, yeah.
So
Is that just a learning tool, or is there any?
there are many, many examples of fantastic applications that have been built.
Can the cat leave a trail like the turtle?
Well, the cat doesn't have to be a cat.
I understand.
So the cat is just a sprite, and you can have multiple sprites come together. But what's nice about this is these are also open source in the sense that if you publish a game, you can make it available for people to remix. So you can go in, and the same way that Jack demonstrated adding those blocks, you get the blocks that people added in order to make this game happen. So if you don't like, for example, the way that this text looks, but you like the general concept of the game, you could change this text, you could change the icon that bounces around the screen, you could learn how that bounce happened, and there's a great opportunity there.
Why don't you show them the Explore button? Or have you already done
Yeah,
that?
that's where we found some of these games, right? So
basically, that's where you explore the game, basically.
mhm.
And if you go to Studios, and then there's all this stuff. There's also a lot of games.
And there's a bit of peer review going on too, right? So if we go into projects and under games, you can see, for example, that there's the opportunity for people to like things, the opportunity for people to favorite things. And so if we sort by most loved, if I select this sprite and I go back into scripts and I want to have this sprite move or turn or point in a direction, while I am on that sprite, I can add move 10 steps. I can have it move a certain number of degrees. I can have it point in a particular direction.
I have a basic idea.
Yeah?
So take those out.
Okay.
There's two sprites.
I like what you're thinking.
There's two sprites, right?
Yeah.
So take that sprite and let's just paint a simple mouse, or look for a mouse.
A mouse?
Yeah, a mouse.
How about a bat?
The bat looks good.
Will a
Yeah.
cat chase a bat?
I'm sorry?
Will a cat chase a bat?
Yes.
Yeah,
Sure,
why not?
absolutely.
Whatever.
Yeah, for Halloween,
So-
it's keeping in spirit
So
there.
we'll make the bat,
Okay.
and so on the bat you say,
So he's saying that if I choose bat, now any scripting I add will be applied to the bat as opposed to the cat.
and so you take the follow mouse button. Yeah, so basically, and you can move the cat around with the mouse in a certain way. I think we've already demonstrated how you could possibly do that.
Right. So if I say forever move one step, which will mean it moves slowly and it always moves, and then always point towards sprite 1, and then I need to set an event of when clicked.
So then you go to bat.
Uh-huh. Right, so now if I move you see if I move this cat, you can understand how this can make games.
Yes.
Right.
Thank you very much. Very good example. I appreciate it. So, who has an Arduino? You always answer everything.
I just bought a $9 one.
$9? Did you make it yourself?
No, it was a project
On Make Magazine?
that one open source, crowdsourced
O'Reilly?
site.
I'm not
Not
sure.
crowdsourced site, I forgot which one.
So because we didn't have 14 hands go up, let me tell you a little bit about Arduino. So Arduino is a programming and electronics learning platform, really. It's a project-oriented tool. What it looks like is this. I happen to have it. It looks like this. But this is the size of it, to give you some sense. And this is one version of it. This one's called the Uno, and Arduino is kind of a collective brand name. There's one company who develops and distributes these, and then because it is an open source project, the hardware itself, the schematics for the hardware, are distributed as well. So we have other companies who have come along and distributed the same hardware, and no money goes back to Arduino, right? You can go out and buy the various components and make it yourself, because the information for how to make one is out there. If you are not interested in that, you can go to Radio Shack and pick up an Arduino. And you might say, okay, well, let's say that I have one, what do I do with it? And by the way, here are two really great books, both very inexpensive, and this is Programming Arduino, Getting Started with Sketches, and Getting Started with Arduino. This is an O'Reilly book, and this is MH Professional. This is by Simon Monk, and this is by Massimo Bonzi. Massimo Bonzi is a co-creator of the Arduino. The benefit to this is that you have digital inputs, analog inputs. You have the ability to sometimes plug it into Ethernet, depending on the model. This is the Uno. This is the smallest starter model that you can get, but you can get ones that are fully functioning robots. The reason the Uno is nice is because it's fairly inexpensive to purchase. Like I said, you can go to Radio Shack and get one for far less than $100. How much does, you bought one for $9, but how much does the Uno
I
go
think the
for?
Radio Shack is about 35.
Yeah, it's not expensive at all.
It was an open source project.
It is an open source project. Yep. So here we have analog in, we have power input and output. So the benefit to this is that you can, for example, take a sensor like like this. Here is a PIR motion sensor. So if I wanted to create some event based on motion, I could do that. So it might be to update a website, or it might be to send out a tweet, or it might be to turn on a light, or it might be to turn off a light based on motion. It also might use GPS as input. It also might use light as input, or temperature as input, or wetness as input. And you can buy various sensors at Radio Shack or online and plug them in as input on your Arduino, and then program it using an Arduino programming interface that is based on processing. Does anybody ever do any programming in processing? Probably not. But that is open source as well. And as a result, you can very simply say, for example, anytime motion occurs to this motion sensor, I want you to flash this light on and off 5 times. Or
do the various Arduinos use the same microprocessors?
they do.
Yeah.
But if you get the different models, usually it means more input and output. Usually you can use higher voltages with those particular boards and so on.
Which specific microprocessor does it use?
It uses the...
Atmega?
Yeah, the Atmega. Do you know what the number is?
No. I don't remember that.
Does anybody know about the Atmega processor?
But there's a whole series of them with different memory and voltages.
Right, they all have different capabilities and different...
Is it an 8-bit or 16-bit microprocessor?
There's one that just came out with a 32-bit.
It varies according to the model. So I believe this is an 8-bit. The next model has an 8-bit as well. The next model has a 16-bit and so on. So all the way up to a fully functioning robot that has wheels on it, etc., that comes pre-built. But you can build it from scratch because it is an open source hardware project. So as a result, if you have ever dabbled with electronics, this might be an interesting way to a platform, essentially, to be able to work with those electronics without having to build up to this system from scratch. Although you could if you wanted to.